4/3. What's this? 2 over n. This is going to be
2 over 3 and 2.
So now, what do you know about things as denominators get bigger and bigger and bigger? What are these going to?
Get smaller.
So this is actually going to 0. That's actually, so 4/3 plus 8. Hmm? How many thirds is 8?
It's 24 thirds.
So 24 thirds plus 4/3, 28 thirds. Okay, that's our process for finding areas under curves.
Those are tenths.
Yeah, so if you remember, you ever watched the movie A Beautiful Mind? They used to show it in health classes when you would do like the mental health units and everything. This is what the guy's actually writing on the windows in the library, things kind of like this. When he's having a couple of his episodes. Okay, so yeah, this is pretty algebra intensive.
Yeah, I can do that.
Okay, so this can't really be done too much on a calculator.
Yeah, I can do that. I feel like the other stuff is way harder. Whatever we did last section.
The U substitution,
Yes. For sure. And the whatever other chapter.
okay, so now we're actually going to get to finding the areas now. Okay, so like we said, you got 2 types. Okay, well actually 3 types. Okay, one where you're going through the right endpoints. One's where you're going through the left endpoints of the rectangles. Then you also have ones that we can have going through the midpoints. So they can go through the midpoints of the rectangles. Okay? So this is going to be coming up later next chapter, but we'll be getting to finding what's called Riemann sums.
But that's not for college, right?
So it's named after the guy, that's his last name, but it's the person who came up with kind of this idea and doing things this way for finding the areas under curves. That's why they're called Riemann sums coming up in section 4. Okay? So right now, okay, we're specifying how many rectangles we're going to use. Okay? So, one thing we have to know, what is the function? What interval are we on? Okay, how many different rectangles do we have?
5.
Okay, got 5. Okay, so we know we're going from 1 to 5. First, second, third, fourth, fifth. That's why it's from 1 to 5. First interval up to the 5th interval. Okay? So now, okay, if I'm splitting this up into fifths, how wide is it from here to here? So if I divide it by 5, what's the width of each rectangle going to be? That's your width. Do you remember how before we said, when I showed you that previous problem, length times width? Or height times width, okay? What do we need to do then to find what these y values are?
The equation.
Okay? So this right here,
We plug in the values.
okay? So this would be 2/5 right here, right?
Yeah.
This would be
Four fifths.
4/5, 6/5, 8/5, 10/5 is the same thing as 2. Okay? So, sometimes you'll see it written as this. Because this here's the first one, right? So the first one's going to give you 2/5. So if I bump up to the second one, there's my 4/5. If I bump this up to 3 now, just like terms in a sequence, there's going to be my 6/5. Bump up to 4, there's your 8/5. When you bump it up to 5 then, there's your 10/5, which is 2. Okay, so now we're going to have to actually plug these in. What's the original function?
Negative x squared plus 5.
So I've got to find the length and width for each of those 5 rectangles now. Okay, so when n is 1, what's the first one? What do you get inside?
And then you have negative 4.
Right? That's the first one,
Okay, so,
because this is, when n is 1, you get 2/5.
Yeah.
Okay, now 2/5 squared, is it 4/5 or should it be 4/25?
4/25.
Because you got 2/5 times 2/5, so it's 4/25. Okay, that's the first rectangle.
okay, so you have to do that for each.
Now we're going to go to the second one. Yep, we've got to do this 5 times. Okay, so now when this is 2, okay, 4/5, when you square it, what is it?
16.
So that's going to be the height, then you got to multiply it by the width, which is always going to be 2/5. Okay, now the third one, so 6/5, square it, and again, always, that width is always constant, always the same, okay? So 4, what's 8/5 squared? Okay, so you can kind of see this isn't a real quick process. And then we're going to have over there, okay, the 10/5 squared, so you said it's 2. So this is what we're going to pick up tomorrow, okay? Tomorrow, we're gonna get then to when it might be 100 rectangles or more. That's when we start getting to limits. Okay, so this isn't gonna be a super quick process. Okay, so we'll finish things up on Friday there, since we're only half-hour period here today.